We're going to be teaching you all the fundamentals of design today and how that's sort of integrated into this technical process that we've been working with. Yes, design with an emphasis on 3D modeling. We've already done our introductions. So now we can, I wanted to introduce some future technologies. Anthony talked a little bit about to you folks what we do today, or what we do here. So we wanted to get everybody really excited about everything that we're about to teach you guys. So that's why we wanted to show these projects to you. All of these were made by by GIM students on the development team. So a lot of the knowledge that they had to learn, like you'll be learning today, was used to create these awesome technology marvels. Just a few terms to know before we get started with this, just because they'll come up a lot. I'm sure a lot of you are kind of familiar with virtual reality. That's an experience that fully immerses you in 360 degrees. Some examples of that would be like a game called Beat Saber, or there's a VR version of Skyrim now, but also roller coaster games in like carnivals and at like Wahoo's. They have you in like a actual physical location, but it's still considered a virtual reality game because you're simulating that.
I wanted to mention that for virtual reality, the distinction between a 360 video and virtual reality comes with the depth and like being able to interact with the environment. So with a 360 video, you're typically just viewing it, and you aren't able to move in virtual reality space, like in that environment. But for a virtual reality, it's an actual 3D simulated environment that you can interact with and move in. Yeah. Sorry about that.
Another term that you're probably a little less familiar with is augmented reality. And that is a term that'll probably change to a little more palatable, like mixed reality. It's basically, you can see here, Pokemon Go is an example of augmented reality. It's taking footage from your mobile device's camera and overlaying artificially created elements like this Pikachu. Gamification is a really important term because that's pretty much all we do in GIM is we are taking problems, providing technical solutions, and a lot of the time we are gamifying those solutions. It's really powerful for people to learn new tasks when they enjoy what they're doing. So when you design it with game elements, it's a lot easier for people to have like a more intrinsic motivation to do what you're asking them to do. So it's really, really valuable. So first up, we're going to show you a virtual reality experience that was made a couple of years ago in the GIM dev team. Users will learn the process of skinning an elk. Basically, the problem here that Idaho Fish and Game was wanting us to solve was that not enough hunters knew how to properly tag and skin their animals in the wild when they actually shoot an animal. So they wanted us to make an experience for them to get them more comfortable with that before they actually go out in the field. So we will watch a quick video about that.
Do you want to talk a little bit about your experience actually being in it? Since you guys can't experience it, he'll kind of tell you about it.
Yeah, so we were hoping to have this live demo for you today, and I would be talking about this as I was showing it to you, but what I will say instead is that I never had used the application before I was trying to demo it, and I was really intimidated because I don't hunt, I don't skin anything. I've never done that kind of stuff before. I'm a scholar. I'm inside all the time. So, so I was excited to try it, and it was amazing. There was so much educational sort of dialogue happening where it was sort of guiding me through the experience. But I found as I was going further along, I didn't need it as much. I started to be able to intuitively understand what I was supposed to be doing. This is a video that is published on the actual Idaho Statesman, so it's pretty cool. Oh yeah, we'll watch an ad first.
One of the big barriers that we found with people getting involved in hunting was the intimidation factor related to the field dressing of a big game animal. We're always wanting to provide more tools for hunter safety, provide more instruction that can help people gain confidence in being able to go out and continue to hunt and fish in Idaho. So it's telling me to start back here. I grab this handle, and it's telling me to go back here. Oh, I gotta go under. So we get this inside of the leg here.
we have been hunting once. Like, we didn't actually shoot. We were part of it.
Sure.
Because we did it with Fishing Game. We did some 360 video filming, and we were spectators.
But now that we've worked on this so much, we definitely could like go out and do this, so, which is awesome. Just the point of it.
At all now?
Yeah.
Definitely. I would be down to go out and shoot a note. Peel the skin off.
I'll let you shoot it. Or no, I'll shoot it. You peel the skin off. Okay. Alright, and that's all the meat pieces we have right now. Let's see, I've got my legs over here, my back strap. Yeah, that's what we got.
All right. Okay, so that was a pretty awesome demo of our Idaho Fish and Game project. I don't know why it's not full screen anymore.
Awesome.
There we go, thank you. Okay, so the next project that we're going to show you is an augmented reality app. So it's not virtual reality. It's going to be on a tablet or an iPhone. Users learn the fundamentals of handwriting using an augmented reality app called ABC Stories. And I was actually the art director for that app, so I know that one inside and out. The video I have for you, I'm going to mute just because I just want to talk about the various things that we're going to show you here. So as I mentioned before, it's a handwriting application. And one of the big benefits with augmented reality specifically is that we found it super helpful for education because it's really engaging in a way that like is more accessible than virtual reality. So students can, instead of like being restricted to using one headset to get this cool experience, they can just group around one tablet and they can all share the experience together. It becomes more collaborative. With handwriting specifically, we wanted to gamify it by basically creating these short stories that walk the students through how to learn writing different types of letters. We have several mini games and practice areas of the app to actually practice the fundamental sort of strokes that are involved in handwriting. We coordinated everything on the app so that it is structured in a way that students naturally learn how to write as they age up. So we start with writing straight lines, we switch to curves, then we switch to diagonal lines, and then sort of all of those things combined. So as you can see here, we have a 2D part of the app, which is where you're actually doing the writing. The augmented reality part is only in the story section. So let me bring that part up. We've got a lot of fun art and really cool, engaging material here. But here's an example of one of the 3D environments that is in the app. So when you're going through the process of learning how to write each group of letters, there's a different story for each group. This is one environment that you see. This is, I think, chapter 4. Basically, the student in this chapter is presented with a character called Keely the koala, and she is a nurse, and she's basically going around to the various different animals and helping them with medical-related issues. So as you're helping Keely do these things, you're learning how to write each letter that's associated with these animals. So it's a really fun way to get students moving, to get students excited about learning and engaged in a way that, especially I would say with handwriting specifically, was severely lacking. I remember hating learning how to write handwriting, just writing like 5 Ks in a row, and like that was how I learned K. This is so much more exciting. So yeah, as you can see, we're tracking anytime a student is drawing in the correct area. We have a lot of positive feedback throughout the app that's designed to sort of help them figure out, oh, this is what I'm doing right. We didn't want to have a lot of negative feedback for them, like showing them, making weird noises when they did things wrong. We really didn't want to stress any students out, especially when they're learning something like this, which is going to be used throughout the rest of their lives. So we really wanted to create a fun, engaging, and fail-safe environment for students. But yeah. So it's really fun being able to, when you place the environment down, Lauren, when she was filming, wasn't walking around too much in the recording, but you can physically move around and the 3D model will stay in the same place. So you can zoom in, you can get close, you can see the entire scene, or you can choose to focus in on the characters as they're moving through. So that's ABC Stories. How do you do the thing? What do you press to get it full screen?
F11.
Oh, so much. Okay, awesome. So our next augmented reality application is one that we actually made with Gear Up. Last semester, we coordinated with a group of students from Nez Perce, and Patrick Gallagher was our coordinator, and it was just an amazing project. We got so much student artifacts from that project. Animotions is an augmented reality app that's designed to help students that struggle with emotional recognition. So, for example, people that are on the spectrum or people that have other sort of social development disorders. Recognizing how people are feeling just by looking at their face can be hard for some people. So this is a way that we wanted to give them a fun way to sort of practice and build up those muscle memories. So here we go.
And we'll give a quick shout out to our old coworker, Justin, who graduated and so left us recently. But he was a big part of this project.
Yes, he was. He was the main coder behind everything.
Mm-hmm. He was actually the founder of the app idea in a class that we were taking. That him and Justin actually were a part of the original version of this project in a classroom setting, and then it became a Gear Up project with the students.
Yeah, it was super cool. The original version of this app was made in Unity. Because we didn't have access to all of the Apple technology that we needed to get the cool facial recognition stuff working. They have a lot of built-in stuff with Apple, so it was kind of a bummer that we had to use Unity for the prototype, but we really got to finalize it in last semester. It's looking really cool. So there's a lot of statistics that track like how long you're spending in each lesson, how accurate you're being, and here we have a little emotional review sort of section that just gives general information about each sort of expression and typically what those expressions mean. There's different options that we wanted to include to make it accessible for students that respond better to different types of feedback. Let me see. Yeah, so Justin is going into the app, and this is the dog mask that he and Finn designed. And up here on the screen, there's a prompt that is basically asking you, it's giving you a real world situation. Like, I think that one was asking you, how would you feel if your friend suddenly came over to your house and surprised you? So the obviously correct response to that would be surprise. So the app will recognize when you've made that face, and once you have, it'll give you a little ding like you did the correct expression, and it'll move on to another scenario. Or you can do this free play section here and just practice the expressions themselves. Anytime you make a face and you press the button that's associated with that expression, you'll get points. And all of the points in the app are used in the store to purchase new face masks. So as the students progress in the app, they can afford to purchase more exciting masks. And I believe 9 of the masks that we included in the final app were designed by students from Gear Up program last semester.
We had 9 student artifacts at the end of that semester.
Here we do have one section that we thought would be valuable just because detecting emotion through text is also another sort of emotional related issue that can be hard. So Justin worked with this really cool, I think it's an AI that is trying to detect emotion through what you're typing. Just another way to sort of practice that. But beyond that, it's just a really fun app. You know, I think it's really cool, and I want to talk a little bit about the power of abstraction in this case. The human face, when you look at it, like obviously most of us are used to seeing a bunch of faces. We know what each expression typically means, but for somebody that's not used to that, they're not sure what to really pay attention to. So with abstraction, we're taking all the important elements of the face, and like the eyebrows, the eyes, the nose, and the mouth, and we're just focusing on those specific parts that really make an intense expression. So that makes it a little bit easier for people to start off paying attention to just those few details, and then they can move on to realistic human faces. And that is Animotions. Okay. Press F11. Thank you. Okay. All right. So I hope that seeing some of this technology was exciting for some of you, because it was really, really cool making it. But what's really even cooler to me is that I started the game program with pretty much no programming experience whatsoever. I didn't know how to 3D model. I didn't know how to do any of that stuff. I came in with 2D illustration experience, but that was about it. Through the GIMP program and learning all the things, how to be a developer, I had no idea I would be able to someday make a 3D environment like this. I actually made all of this. And I'm really proud of it still, even though it's it's beginner level stuff, but I'm pretty happy with it. And I just think that the stuff you can learn in a field like GIM can really surprise you. Okay. So our overall goals for the whole camp, we just wanted to touch base. Anthony mentioned this a little bit before. We are not by any means expecting you all to become expert front-end developers. That's not the goal. What we want is we hope to teach you enough that you're going to be able to understand the sort of problems that come up as your students are going through our tournament. So we're hoping that you'll be able to at least know enough that even if you don't know for sure what the problem is, you know where you can sort of point them to get help, or you can even just help them yourself if it's a simple enough problem. The skills that we're going to teach you and that being a front-end developer you have to sort of master are really helpful just across the board, pretty much everywhere in life. So just some skills, especially to help you keep up with the job market as it continues to advance and technology changes every day. Some of the really important skills I think that being a developer helps you master is critical thinking, advanced problem solving, team and project management. You are constantly having to adjust your expectations and reframe your thinking. And it was cool joining the development team because I thought, well, these guys are super smart. They know what they're doing all the time. How could I ever be on that team? And then I told Anthony, I'm available if you want me. And he said, yeah, I want you. So I joined dev team and nobody had any idea what to do. Everybody was learning constantly on the fly. We all have like some skills that we came in with, obviously specializations and interests, but beyond that, a lot of what we do is figuring out new solutions as they come up and trying to adapt to new technology as it comes out. And one more thing I want to mention is that the real world need, when you're creating projects like this, having that like sort of motivation behind everything, it's like really, really important. It's something we want to impart on you and your students as well. When you have students and a project together, you might get something good by the end, like they're motivating themselves to get it done for a good grade, whatever. They might give you something good, they might not. However, when you have students, a project, and a real world need, something where they can say, I'm making this for this problem. I'm going to see this in the real world helping people. The motivation levels go way up because suddenly the stakes are raised. It's not just a good grade you're shooting for. You want to actually do something with what you're learning. So that really helps students see the point of what we're teaching them immediately. Because like I mentioned before, on the dev team, the whole development process, we're solving problems as they come up. So when you see like a problem and you're getting involved that way, it's really easy to motivate yourself to get it done. What we wanted to do for the camps to sort of hint at how important that is to have a greater purpose behind your education, we are going to be presenting all of this information to you through the creation of a simple 3D game. So by the end of the camp, you should all have a game prototype that you'll be able to play and say like, oh, I made all these assets and I made most of the programming. Like, it's super cool. We wanted to do that because we wanted to help you see the point of what you're learning. But also, it's going to give you a lot of foundational knowledge that you can then expand on later. A lot of the skills we're teaching you can be applied to pretty much any sort of program that's an equivalent. So it's really good stuff. So the game itself, like I mentioned, we want you to learn just the essential elements of what it's like to create a game start to finish. We want you to become familiar with how front-end development typically works. And when I say front-end development, I realized I didn't sort of do a definition there. The difference between front-end development and back-end development is that, like, in computer science programs and stuff, they typically focus on back-end stuff. That's all the data, that's all the math, that's all the hard-coded stuff, that's the stuff behind the scenes, basically. And in front-end development, you're concerned more with how the program is interacting with the user. So we're making stuff that the users are going to immediately see, that they're going to be able to touch, that they're going to be able to do all kinds of stuff with. What you guys will be responsible for making for the game is today we're going to be showing you how to make all the visual elements of the second level. And the reason we picked that one is because it's sort of the simplest out of all of our environments for this game that we made. but it has all of the essential elements that the rest of the game uses too.
I do want to mention that the storage crates, for purposes of time, we decided not to go over that in the tutorial because the skills that we show you in the complex cube model, the interactive cube model that we're going to be making with you, you can use those skills to very easily make a storage crate object. They're using the exact same process and skills. In fact, it's less detailed. So we aren't going to be showing you every single thing in this room that you see just because of that, but everything else.
Yes. And then tomorrow, you'll be learning some programming. You'll be programming all the main elements of each level. So you're not going to do every single thing in the game, but just the really important stuff to give you, again, that foundational knowledge. So in level 1, you're going to learn how to program a jump. Level 2, you'll program how to interact with an object in the scene. And level 3, you'll learn how to do a projectile script so you can throw objects. I just realized that this is...
That's okay.
Okay. One of the most important takeaways that we really hope you learn through this whole experience is just how important it is to have purpose in your designs. Design with intention. You're not just making an art piece for the sake of art, which I suppose you could, but when you're creating something that a bunch of people are going to use, you really want to have intention behind what you're making and know sort of why things look good, why things don't. Okay, so here I wanted to show you, this is the game finalized.
And so another thing that we won't be going over with you during this process because of time, it turned out to be way longer during our rehearsals than we thought it was going to take to explain it. But this arm that you see at the left, we're going to show you modeling and animating as well as the rigging process. But it honestly, that's a whole other thing, and just doing that in one day would be a lot. And so we wanted to make it a lot more manageable so that everything that we will be going through with you today, you will be able to reasonably finish and complete in this time frame.
Right. So that's the full game. That's what it will look like when it's completely finished.
But we are only working on one of those levels, which is level 2.
Yes, all the visual elements for that.
For the visual elements, excuse me. Okay. The programming will be going over all 3.
Okay. So yes, we're going to focus on visual design for day 1. We're going to be walking you through this whole process of coming up with ideas for games visuals, and then going through the whole process, seeing them through to completion. That ideation, creation, and then game integration. The terms list is available. I wanted to make sure everybody was able to get access to that. Did you?
Awesome. Very good. Thank you.
Okay, so you should have just received an email recently with a PDF of our terms list, and these are just like all the various like vocabulary words basically that we're going to use, so we don't have to constantly redefine them.
Has everybody gotten set up on the internet on their computers to be able to access that?
All right, so while you guys are taking a look at that terms list, I would recommend just having that up throughout the discussion. It'll be handy to check in on. This is just a sort of a tentative schedule that we have for you, all the different topics that we're going to go over. This is also in your printout inside of your binder on like the second page, I believe. So you do have this. Let's see. So here is the whole design process. We're going to be seeing this graphic a lot throughout the presentation just because I want everybody to sort of be able to keep track of where we're at in the whole scheme of things. So we start off with mood boards, which is when we decide on tone and themes for whatever we're making. That's like, we're not doing any visuals on our own just yet, really. It's just collecting existing imagery that we want to draw from. Conceptualizing and creating concepts, there's 2 major stages to that. You go through the brainstorming stage, which is where you're getting all of your ideas out, as many as possible, and then you have the narrowing stage where you're then taking all of those ideas, figuring out the things that you like, the things that you don't like, and narrowing down until you get a final design. Then you can create reference images for your final designs. So whether or not you draw them yourselves or you can just take photographs, it doesn't really matter. The reference images are then used to create 3D models, and we're going to be working in the program Blender. Afterward, we will show you how to texture those 3D models, which is just adding color and texture to them to give them a little bit more life, a little more zest. We're going to briefly go over animation, which is for 3D animation, you have to set up a rig. It's basically a digital skeleton for your model. But for 2D animation, which is what we're going to focus on with you guys, it's a lot simpler. It's just one frame, one drawing, basically. And then Finn's going to show you how to import all of those assets that you create into the game engine Unity, how to set your scene up so that you can get ready to code tomorrow.
And by one frame, one drawing, he means, every frame is a drawing, not this is a one frame animation, because that would just be a picture.
Yeah. Okay. Let's discuss mood boarding. Okay. So, what is mood boarding? This is not it's not a necessary step, I would say, but it is something I found super, super useful. I've recently really started using it more just because of how useful I've found it is. It's a really good first step when you're creating designs for a large project, but you could do smaller projects too. It's basically a collection of images that you get from outside resources or photographs that you could take yourself. But it's used to help figure out what sort of aesthetic tone you want to convey in your design, any sort of important imagery, as well as how you're going to convey the goal or the purpose of whatever you're making. So here we've got this really cool mood board up here for I would say this words that come to mind are cyberpunk, futuristic, dystopian. Here we've got a mood board for a wedding, which is a completely different vibe. It's a lot lighter. Clear they want to do a lot of beiges, creams, and pinks. But you can really see that even though there's no original things here, you can sort of get a feel for what they're going for, what they're after in their designs.
Very soft. That last one.
Yes. So how did we use it in our process of creating the game that you're going to be learning to do? So this is the mood board that Dylan and Brandon actually made for Finn and I before we started creating all the visual elements. They wanted, they knew at the beginning they wanted to create a puzzle game, just a really simple game that you would be able to sort of put any kind of aesthetic or design over the top and it would work. Something that would be simple for you guys to understand that we could program with you. So one puzzle game that I don't know if anybody's heard of, it's called Portal. It's a pretty famous game, and that's the kind of aesthetic that they wanted to draw on because Portal is a puzzle game, but it also has a really sterile sort of hospital-like environment, and that's really the feel that Dylan and Brandon wanted the art to have. So this was the very first thing that we received before we started creating concepts. So the important considerations when you're creating a mood board, you want to obviously recognize what am I creating? What is this mood board going to be used for? What purpose is it going to have? So obviously in the way we used it, we knew we were going to make a puzzle game. So right before they created the mood board, they were thinking, what puzzle games could I draw on? What sort of vibe could I use to make that work? Another thing that you should consider is once you figure that out is the sort of keywords that you're going to be searching for when you gather these images. That's actually something that I struggled with when I was creating designs for the example here. So having something in mind is really important because then you'll be able to find those images a lot quicker. The other things you'll want to consider are the colors in the images you include, any important objects, settings that are relevant to what you're doing, or any symbolism. And I have this big graphic here that says, don't get too hung up on making each image perfect. And the reason why I say that is because there's a lot of images out there, and we're only going to give you 5 minutes to make one yourselves. So you don't need to like every single thing about it. But as long as you can look at that image and say, I know what I like about that, what I want to include in my project, in my design.
Think of it both as a package, the entire mood board, what kind of feeling and what kind of vibes do these give me, and not think of everything in the image being representative of what your idea is. Definitely make it a gut feeling and trust your instinct on that one, but also be conscious of what you like about what you did put in there.
Mm-hmm. Okay. So now we get to do a fun activity, which is where everybody's going to create their own mood board. The first thing I wanted to do was sort of walk you through this process, but I'll explain it first. And you can because you're going to be creating all the visual elements for your games, you can potentially use this mood board for your games designs if you want to, but you don't have to. You can just copy the stuff that I'm going to be showing you later. Okay, so now that we have all become familiar with the first part of the design process, we are going to move on to the second part, concepting, which again is brainstorming and then narrowing down final designs. Okay, so the two stages of concepting. The first, brainstorming, is highly creative, unrestricted, don't give yourself any rules. The goal is to get as many ideas out as possible, just because our first ideas are very rarely going to be our best. So that's a really important step that you don't want to waste or cut too short. The second is narrowing down a final design and trimming the fat, so to speak. So you're looking at all of the ideas that you've brainstormed here and figuring out, what do I like, what do I not like, what elements do I want to keep, what do I want to lose, and figure out what you're going to create for your final design. So in this case, creating this is a face mask design that I created for Animotions. After I brainstormed a few of these designs, I decided that I really liked the color palette of this one, but I liked the horns and the little ear tips of this design much better. So that's what I ended up adding to this to create my final design. Okay. So concepting, and how did we use it in ours? Unfortunately, I don't have any really cool, fun concept art to show you for this game, just because we were on a really big time crunch and I couldn't spend as much time on this process as I would have liked. So what I did was, once we knew what the sort of elements were for each level, I just created various concepted floor plans, which I started like filling in the areas with different sort of objects and thinking about, what do we want to include besides the main elements of the level? And after our concept was drawn out, Finn was able to create an asset list.
I'll go ahead and talk about that. So I got this from Aaron. Like he said, he drew out a concept of a simple level design, and I just took the concept and I wanted to look at it and pick out objects that were on it first. So starting from like the outside going in, obviously we're in an enclosed space, we're in a room, and so we've got floors, wall, and a ceiling, very simple shape. Storage crates, which were used for decoration. We got maybe a large variation, maybe a small variation. I was seeing a button in the middle, a cube, and the portal, which are the main elements of the level.
So some important considerations when you're creating concepts is that you want to remind yourself of what the goal is. You want to find the best possible design solution by, again, brainstorming and narrowing down on your final design. And you want to ask yourself, does it meet my original goal? For example, the goal that I had when I was creating concepts for that face mask was, these were the things that the design needs to have. It needs to be a deer, it needs to be cute, and it needs to function as a face mask. So that is definitely what I would say all of those are hit here. This is definitely a deer, it's definitely cute, and it has all of the essential elements of the expressions that we were going to incorporate into Animotions. So before you narrow down your design, you always want to ask yourself, is this really meeting my original goal? And if it's not, then go back to the drawing board. So now we have a fun activity for you guys to create your own concepts. So we're going to have 2 5-minute activities. The first is going to be doing the brainstorm session. And we have 2 different sort of things that you can choose to do. We've got a prompt for you to design a collectible cube for a game. And in the concepting stage, just focus on this grid here. Get out as many designs as possible. The thing to consider here is, what does this cube do when a player picks it up? Does it give them health? Does it make them faster? Does it damage them? That kind of thing. And the second option that you could choose, if you don't want to do that, is you could design a hairstyle for a character. And we're going to talk a lot about character design later on. But the thing I really want you to consider while you're doing this is, how does the hairstyle that you've drawn convey the character's personality? Is their hair neat and tidy to suggest that they're kind of a prim, polite character? Or is it really like wild and crazy to show that they're more carefree? Stuff like that. So go ahead and take 5 minutes. If you look in your binders, you'll have all the papers for these activities, and you should have pencils as well. go ahead and brainstorm some concepts for one of these two options. All right. So once again, checking in on where we're at in the whole design process, we have gone through mood boards, we've gone through concepting. So now we're going to discuss reference images and how those are typically used. Okay, so what are reference images? So it's hard to wrap your brain around what a reference image is used without thinking of a 3D model, because that's typically what they're used for, unless it's for 2D animation and you're needing to see multiple angles of the character. You want to make sure everything stays consistent. So the 2D reference images are 2D images of all the important angles of whatever you're trying to create, whether it's that 3D model or an animated character. Typically, the most important angles are the front and side. However, that is not always the case. For the object that I used reference images for this game, I actually needed to use a top-down reference image as well as a side. Drawn images or photographs will work for your reference images. Whatever works best for you. Depending on what you're creating or where you're at skill-wise, reference images are not always necessary. However, they are very, very helpful when you're modeling something that's a little bit more complicated or has a lot of detail that you have to keep track of.
I wanted to mention something with that drawn images aren't always necessary. When it's real objects, taking pictures, that can be really beneficial, especially if you have access to the objects themselves. I 3D modeled the entire GIM lab recently with the help of Zeke, and we just used images of the actual objects themselves. But the benefit for creating reference images is you can create whatever you want. It doesn't have to exist, and you don't have to have it in front of you.
Absolutely. So I used reference images in the creation of our 3D game when I made the player's arm. The arm that you saw that was to the left of the screen, that it was picking up the cube, that is the player arm. And since that was the most complicated object that we were going to be 3D modeling for this game, I went ahead and, Finn actually concepted the arms out for me. He sketched these before, and then I added all of this nice detail on top.
I basically did the first part of that activity you just got back from, the concepting and adding, coming up with that, and then he took that and created this final design.
Yes, absolutely. We combined our forces for these arms. But what I was kind of thinking about here is that the reason we needed reference images for this was because, again, it's the most complicated object, but also there's multiple parts to it. And that's really one of the things that distinguishes between a simple object and a complex one. So I'll talk about that more in just a moment. How do you make reference images? So what you do is I've drawn down here for that lovely little deer design I had before. Usually what you're going to want to do first is draw the most important angle. In this case, the face, the front angle is the most important. So this is what I drew first. Then what you do is you add guidelines over the top of that first image that you draw that marks all the locations of the important features. So for example, I've got a guideline up here letting me know this is where the tops of the antlers start. This is where the tops of the ears start. These lines encase the eyes, the face. All of these lines are basically going to help me make sure that when I draw the other angle, all of those same features are exactly in the same spot they would be if you rotated it in a 3D space. Okay.
All right. Yeah. Is that my all right. I'm going to take over from here on out. We're going to start talking about 3D modeling and the Blender program. And so if you haven't already, what?
That's fine. I didn't include that.
Oh, excuse me.
We're switching up on the design process. I apologize for not including that graphic again, but now that we've moved on from reference images, we didn't want to, we're not having you guys create any complex objects for this just because it would take a little too much time. So the next step in the in the design process is 3D modeling. Actually taking those images that you needed for reference and creating 3D things from that.
I mistook the...
You want me to go over this?
No, this is yours still. I mistook that 3D modeling of the design process for intro to the 3D modeling section of this. So sorry about that. Continue.
That's okay. So a lot of you are probably not that familiar with 3D modeling. So I wanted to just have some introductory sort of terminology as well as get your head wrapped around what we're going to be doing. So when you're drawing on paper, like you were for those concepting and all that process, you were creating two-dimensional things. You were drawing on a flat surface. A clay sculpture, meanwhile, is three-dimensional because it can rotate, we can move around and see all the various angles of it. So everything in our world that is not flat is 3D, including your chair, this building, you. Most things in our reality are 3D. So while sculpting in real life creates a tangible 3D object that you can touch and see with your real human eyes, 3D modeling is the way that we create 3D objects in a digital space that we can use to program. So, okay, so there are a lot of really cool ways that 3D modeling is used. I believe at its start, it was probably mostly used for production and other sort of behind the scenes things, but now that it's an art form, it's sort of taken off, and we see a lot of really cool things as audience members, things like that. So CGI, or computer generated images, is one of the ways it's used in commercial, like film and TV. The 3D model of Drogon up here from Game of Thrones, I believe they used Maya, 3D modeling program that we are taught first in GIM, which is super cool. And down here, you can actually see what this looks like in real life. Amelia Clark is sitting on this lovely rock, and she's got this cool little green puppet with various points on it to mark just sort of for the animation, or the animators, when they're laying over this 3D model on top of it. They need to know where all these little dots are to place the 3D model properly. But that's what that ends up looking like before all of the textures are applied, just the model.
A lot of people view motion capture as like a 3D scan of the person somehow animated. No, it's just like a tracking of specific points that they're, that's why you see them in the silly outfits with like the white dots. It's just the tracking of points, and that is a cue for the animators to know what parts of the mesh to place where during that animation process.
Yes. Another way that 3D modeling is used as an art form is in 3D video games. So I'm sure all of you have heard of the Mario games. They weren't always 3D, but they did make a jump with, what game was it?
Nintendo. It was Super Mario 64 for the Nintendo 64. That was the first 3D Mario game.
And the graphics for that were a lot more simple than they are now. Their latest Mario games have such beautiful 3D graphics. It's really phenomenal. It's also used in a lot of 3D animated films, and we're going to go ahead and skip this link. I wanted to show you a short film that was created using Blender, but just for the sake of time, we're going to go ahead and skip that.
We do want to tell you that it's called Spring, so and it's included here, and you'll have access to this PowerPoint. So if you do want to look at something that is really beautiful and is capable to be done in Blender, I would encourage looking at that in your own time. But yes, let's move on to save time.
Okay. So how it's used commercially in business, it can be used in architecture, manufacturing, education, and training experiences, kind of like what you saw with the elk. These are some of the industry standard 3D modeling programs. Blender is the one that we're going to be showing you how to use, but I did just want to mention that my uncle actually uses AutoCAD at his production facility in California to create like medical equipment. So 3D modeling is really, really valuable in the business world too. So just some basics about 3D modeling itself. Some 3D modeling, like the way you do it, is done in a way that's really similar to sculpting in real life, where you have an existing thing that you're working on and trimming down. But we don't recommend starting that way. We didn't want to teach you that method, just because traditional 3D modeling concepts are way more like widely applied.
So since we're thinking of 3D modeling more in any industry, I would say except for just artists that want to sculpt, a lot of the time there are so many artists who use Blender. They create a mesh with so many faces and they sculpt using the software in a different method that we're going to be showing today about 3D modeling. But usually because of the fact that there are so many polygons, there are so many parts to this model, and I'll explain in a moment what they are individually. We've got key terms that explain them. I'm gonna actually no, I'm not. Okay, the more of these little like faces that you see here, that's what these are. They are a connection of like 3 or more vertexes. So with two vertices, with two vertices, which are like the smallest point of a 3D model, they're these little tiny dots. 2 of them connecting makes an edge, but that doesn't make a face. That line connecting those 2 vertices, that is an edge. We see them as, we call them edges on our actual surfaces. Vertexes, we tend to call things like that corners, like sharp corners on the model. That's another way to kind of look at it. But polygons are made out of 3 or more vertexes that are connecting together, or a face, excuse me, is 3 or more vertices connecting by edges to make a closed shape. And that's also known as a plane when, especially when it's like by itself. You can add a plane, which is just a square, a 2D square, but it's in 3D space. We'll show you about that later. But that sculpting, the reason why we wanted to mention it is because we think that it is a huge misconception that when you think about 3D modeling, you think about chipping away at something that is already existing, and a sculpture, modeling clay. And it does exist, like I said, but it's not good for video games or for anything that you need to like render. It takes a long time to produce that many surfaces.
Because there's way too many faces on those. So the way we're going to show you how to 3D modeling, you're limiting that number of faces so that whatever you import it into, it will run much smoother.
The way we 3D model, it's to make sure everything is as efficient as possible and that the texture is doing most of the work of the details. We try not to add any details with geometry, which, are these faces, these different components, unless we have to.
Yes. So how I wanted everybody to sort of think about it is instead of like sculpting in real life, think of it more like paper mache. You're wrapping planes around in a hollow space to create the 3D object. And like Finn mentioned, the various parts, you start, you've got a full polygonal model here. This is a 3D model. It's made up of various faces. There are several here. And each of these faces is made up of 3 edges and 3 vertices.
And by the way, they don't have to be made up of 3, just 3 or more, but we don't recommend at all more than 4. And
yes,
you're like, oh, well, you're telling me just 3 or 4. Yeah, pretty much. You should stick to geometry. Those faces should just be 3 or 4 sided. You really shouldn't have more than that. Otherwise, you're going to have issues in rendering your geometry and animation especially.
Yes, it can be a big problem. So we want to keep things down to quads and tris, and Finn's going to talk to you a little bit about that later. So now we're going to be opening up the program Blender.
Yep, all right, and I'll be taking over from here on out. If you haven't already, go ahead and find that shortcut for Blender on your desktop and open it. And to start off and get you familiar with Blender, I'm going to show you a video that I made for the Gear Up summer camps.
It was last year.
Yeah, it was last summer. I'm thinking already past the summer for some reason. Last summer. And so I'll show you that because it goes over a lot of these different things. I'll stop it here. Hold on. So I want to make sure everybody has the program open before I start. So give me a thumbs up if you've got your program open. All right. We are looking good. Give it a second. Hey, Zeke, are we good over there? Oh, okay, good. All right. And we're not actually, you don't have to follow along with what I'm doing in this video here. You can, we're encouraging you to play around right now. Just play around with the interface and get used to the environment.
Yes.
Hey everyone, this is Finn. Today I'm going to give you a tour of Blender's interface. Open up a new general blend file by either opening Blender or going to File, New, and then General. It starts with a cube, a light source, and a camera, but right now we'll only be worried about the cube. To rotate your camera, hold the middle mouse button, and to move it, hold the middle mouse button while holding Shift and drag your camera around.
We'll go over this
again. You can also rotate it by clicking and dragging this compass, and move it by clicking and dragging this little hand. You can also press Shift and the accent key to enter first-person mode and move around with the WASD keys, which is perhaps the funnest way to do it. To zoom in and out, you can scroll your middle button or click and drag on this magnifying glass icon.
All right, so before I move on in that video, I'm just going to really quickly show that again and say it this time so that more of you can hear. I know that that was a little quieter than we thought it was going to be. I think that that's turned all the way up. So basically, we've got Blender open, and when you open Blender, it's already a new general file. It starts with a default cube, and that's what you want to see. If you want to ever create a new one, like you mess up and you are like, I would rather just start a new file, up here, the file menu, click it and press new. This file menu, it's like any other file menu for like Microsoft Word. This is where you load your project, you save your project. You might want to import a model from a different program. Like if you have an object file, you can put that right in here and start working on it. We'll talk about those different kinds of files a little bit later. Not in detail though, because when working with Unity, we can actually just have this entire blend file, the one you just created, and that's all we need. We don't need to export it, but it will be beneficial to show you how to do that if we have time. So to navigate, which that's basically all I went over in that video so far, is navigation. And this 3D viewport, it can be a little bit jarring if you're not used to navigating 3D spaces without a controller, especially. Like a game controller, you know, like people are used to 3D spaces when they're playing video games, but when they're actually creating 3D environments, it's definitely confusing at first. But it'll get better the more you look at it. I'm holding the middle mouse button, and I'm clicking and I'm scrolling around. So if you don't have a scroll wheel, which everybody in here should, yes, everybody in here should, so you can hold that down as a button. Like don't scroll down, hold it down, and then click and drag around, and that'll move that view for you. Another way you can do that is up here. We've got this compass, and it shows you all your axes. And you want to click on any one of these little circles with letters in them, and it'll do the exact same thing. You click it and drag it around. And so that's how you rotate your view. If you want to like pan the entire view, like move the entire view like this, you want to be holding Shift while you do that. So if you hold the Shift button and then hold that middle mouse button and move around, you'll be able to move your camera, or it's not your camera view, but the 3D viewport, you'll be able to move around the view you're seeing however you want. Zooming in, the obvious one for most programs is the scroll wheel. You can scroll inward to zoom in. I guess maybe I'm just thinking about 3D modeling programs, so I shouldn't say that. Where else do you zoom? Oh, in drawing programs, you zoom in by scroll sometimes too. Anyway, zoom in using that scroll wheel, but you can also zoom in using this button up here. If you hover over it, it says zoom in or out. Click it, and then drag it back and forth, and that's how you can do that without a scroll wheel. You can also move your view around without a scroll wheel by pressing this hand button. You click it and you drag it like you did with the zoom. So basically all of these tools up here, it's basically just click and drag to do the same thing that you'd be doing with that scroll wheel or that middle button. Because you're not. Okay. All right. Let me keep going here on this video. Oh, here.
There are two modes in Blender, Object Mode and Edit Mode. To toggle between them, press Tab. Let's stay in Object Mode so I can show you how to add an object to your scene. Right-click on your cube and click Delete. or press the delete key while the cube is selected. Then, to add it back, go up to Add, Mesh, and Cube.
And
Faster
Control
way
Z
to
is
remove
undo.
The Add menu is Shift A. Over here to your left is your Transform Tool menu.
Oh, okay.
If you can't see it, press...
Okay. Just to go over that again, to delete the object, you're in object mode when you look up here to the top left, and it says object mode on this drop-down menu. That's the object interaction mode, and that sounds confusing. There's edit mode and object mode. Those are both object interaction modes. So object mode it's not short for object interaction mode. That's just what this drop-down menu controls. And so make sure you're in object mode, which should be the default. So you should already be in there. And then right-click on the object, and the very last option, which the shortcut for that is X, but it lets you delete. Click on that, and you can delete that. To add an object, we'll go ahead and add that cube again. You can either press this Add button at the top left over in this header, and you'll see all these options for different things that we can add. But we want to add a mesh, which is, what's the definition? Let me pull that up. I have a really good definition, but basically that's just another word for like a 3D shape. Yeah, you go for it.
Okay, so the definition that we have in our terms list for mesh, and we're going to be using it a lot, so you'll want to pay attention to that. A mesh is a polygonal model made up of faces, edges, and vertices, which creates a 3D shape.
So like I said, it's basically a 3D model. It's a little hard to explain, but it's the same thing. So when I say mesh, I'm just talking about that 3D model. All right. And so add mesh, and then to add a cube, just select cube right here. And that cube will appear again.
T to toggle it on. If you transform.
Now I'm going to be talking about some of these transform tools over in the toolbar.
So what you can use to change your 3D models.
Over here to your left is your Transform Tool menu. If you can't see it, press T to toggle it on and off. Your first tool is the Box Select tool. It lets you click and drag to create a box, and everything inside it will get selected. Next is your 3D cursor. It's that small and red and white circle at the center of the cube. Right now, it's at the world origin, but you can put it right on top of the mesh by clicking anywhere on it. This is very helpful for creating your own pivot points while transforming your object. To reset your 3D cursor, press Shift S and select Cursor to World Origin. The next tool is your Move tool. Select your cube and you'll see these directional arrows, which you can pull either direction to move your object. You can also move the object freely if you click and drag by the center, or by pressing G and moving your mouse around. Next is the Rotate tool, which is...
I wanted to pause for a moment just to mention that we won't need to go over these because we're going to be going over these tools a lot in the demonstration of actually creating the 3D assets. So definitely pay attention for just right now. But I'll be reiterating it, so it's okay if you miss some
arrows,
for sure.
You get these circles that surround your object. You can click and drag them either direction to rotate your object, or rotate them freely by pressing R. Next is the Scale tool. Pull on the boxes to scale the cube's different sides, or press S and pull your mouse to scale the entire object. The next tool is your all-in-one transform tool, which does the job of the move, rotate, and scale tools at the same time. This can look a bit busy, which is why I prefer to select the tools individually. There are two more tools here, annotate and measure, but we aren't going to worry about those today because they aren't essential to the modeling process. Let's switch to edit mode by selecting the object and pressing tab. As you can see, there are a lot more tools in object mode, but I don't want you to get intimidated because we are still only going to be worrying about these same tools for now. Now we can see the vertices of this box. If you press 2, we can see and select the edges, and if you press 3, you can see the faces and select them. 1 is the shortcut for going back to the vertices. Transforming these components individually is the key to creating a detailed 3D mesh. With the Move tool, you can click on a vertex, edge, or face and move it around. The same shortcuts from Object Mode apply in this mode as well. If you press G twice, you can get a slider bar, which can be very helpful when moving edge loops, which we will talk about later on. The Rotate tool doesn't affect a vertex very much, but you can rotate edges and faces however you want. The Scaling tool is similar, where you wouldn't use it on vertices, but you can scale edges and faces like so. And now our cube is a flat screen TV. And finally, we have our all-in-one transform tool. Again, I find it's nicer to use the individual tools because it's easier to see what you're doing and you have more specific control.
Oh, let me get out of there. Oh wait, no, we're not. This is just reiterating that to create a new file, you go to General, and this is a good guide we have here about understanding axes. And the axes, you recognize them from like the coordinate plane in math, like the x-axis and the y-axis for 2D. So in a 3D space, we're going to need another dimension for depth. And so in Blender specifically, I want to mention that this isn't the same for every single program. I think for 3D modeling programs, it is consistent, but in Unity, the game engine, you'll find that the Z and the X axis are flipped. So that's not something you need to remember just now, but remember that it can vary per program. So for now, this will apply for Blender, definitely though. The X axis is the width, this red line here. The Z axis is height, up and down. It's that blue line. And then the y-axis is the green line. So you can't see it on this side because it's going right through there. And so to kind of wrap your head around how they work, especially when transforming your object, I put together a few GIFs. And so this is what it looks like up to the very top left is the first one we'll focus on. When you scale an object by the Z-axis, in that video, I talked about scaling by pressing the S key and then moving your cursor away from the object. If you press S and then the Z key immediately after, you'll scale only on the Z axis. So there you can see me doing that, and you'll see it follows that blue line. Transforming, I'd like to say moving, well, it's not actually, it's called move. So moving an object by the Z axis, by using that move tool, you'll see that it follows that blue line as well. It goes up and down, sliding on that. So I have another little reminder image like the one before, just showing you it goes up and down. And this is what it looks like to rotate by the Z-axis. Sometimes rotating can be hard to wrap your head around, but picturing it as like rotating around this pole makes it easier, rotating around the axis.
Yes, you want to think of all of these in terms relative to the axis that you're selecting.
All right, and so this is scaling an object by the x-axis. It's going outward against that line now. translating and moving by the x-axis, you're sliding back and forth to the left and right, and rotating. This is something that confused me when I first started 3D modeling, just because of the way my brain works. It's different for everybody. But I figured that this was what it looked like when you scale or when you rotated by the z-axis for some reason, because going up and down, my brain was like, yeah, go that direction. But no, you got to think of it in relation to the axis, and so it is rotating on that line there. Okay, and so we've got the same ones, scaling, moving, and rotating. Here you can see
on the y-axis.
On the y-axis. Here you can see it's gaining more depth. It's scaling front and back, or it's not scaling, I meant like moving front and back. And then here we are rotating on that green line. All right. We also wanted to quickly go over the Blender interface. The best way to learn an interface of any program, I think, is to take it step by step into into sections, follow tutorials like you're going to be following with me today. And so I'm going to be explaining what each thing does as we're going along. I'm not going to be able to explain what everything does all in one step, but I will explain the different sections at least. I've color-coded some of the different sections. It can be a little hard to see, but I will explain them all individually. We've got the main region, which is the region that you're going to be seeing most of the time and manipulating your object in. This is the 3D viewport most of the time. Basically all the time in this program, it's the 3D viewport where you're going to be able to interact with that object. Up here is the top bar. To the left, you have some of your file options, like your file menu. Like I said before, you can import, export, load files, save files, create new files. Edit allows you to adjust your preferences for the software. It lets you see your undo and redo history, things like that. We won't be using edit as much as file for sure, but I have a better picture of it in a couple of slides, but right here where the top bar is kind of laying on, I go back. No, we're fine. We might not be going over it. I think we adjusted that, but this is the workspace menu. What a workspace is, it's a saved collection of these areas. So what you're seeing right here, that's a workspace. It's the layout workspace. It's the very default one. You can create one yourself by moving things around, dragging windows around, like adjusting what you want to be looking at. Hold on, let me finish. And then we also can change the type of editor that we're seeing, which these right here are editors. To the right, this one down here, I'll talk about those more later. And then this one down here is the animation editor. They're all editors, but you can adjust what kind of editor you're looking at by clicking this little button right here. It's a drop-down menu, and it'll give you all these different options for different menus. So you can do that and save your own type of workspace once you feel comfortable in the environment. But before that, I would recommend working in layout for now. And the different workspaces that are built in by Blender, which are included up at the top. Layout, modeling, sculpting, UV editing, texture paint, shading, animation, rendering, compositing, and scripting. Those are the built-in layouts, but the ones that we're going to be focusing on are layout, UV editing, and shading. Here we've got our header, and that's where you saw this object interaction mode drop-down menu exists. It also has other drop-down menus like view, select, add, and object. You saw me open up the add menu a couple times to add that cube. That's part of the header. This is the toolbar, and I just went over this, so I'm not going to go over this in a lot of detail, but this is just the tools that you use to modify your mesh. This is the sidebar. You can find different, lots of different information of the location of your mesh, the rotation, the scale, and the dimensions. Right here you can see that the location and rotation are 0, because you haven't actually made any changes to modify that mesh yet. So it's at its base level. Scale is 1 because that's what it means to be at the normal size, basically, for an object. If you increase the scale, that number gets larger. You decrease the scale, that number goes smaller until if you get to 0, that object won't be visible. And I did talk about the editor menus. These are different menus that you can use to edit things. That is a bad way of saying it, but it's very self-explanatory. These are the main ways that you're going to be accessing things like this. It's better for me to explain what each one does. So what we're looking at is the outliner up here. It's the very top right. That is an editor for keeping collections of. It's everything that is in your scene. So you see right here, it's a camera, a cube, and a light source. And what that means, is we have a physical, or we have an actual object in the scene called a light. We have one called a camera, and that's used for rendering. And that's we're not going to be using those two objects because we are using a game engine. That's the end goal of this, is to put into a game engine. And so we're not actually creating like our own animated film or anything like that. We don't need a camera or the light source. Those both are going to exist in the game engine that we're going to be putting them in. So for the end of all of these, we're going to want to delete both of those objects. But that's just me explaining what this is. The outliner, it contains all of the objects in the scene. We also see our cube. This is the properties editor. And it basically just has a bunch of little menus where you can access properties of different kinds. So there's something called the modifier menu, modifier properties menu, and you can add modifiers to your mesh. And those are things that change. They modify the way your mesh acts or looks or behaves, but not permanently until you apply that modifier. So some of this might be a little confusing as I'm going over it. Don't worry, we're going to be revisiting these concepts. And then down here is an animation timeline. And so anybody who animates is going to need some kind of timeline to place where the animation is timed out. This is a sneak preview of all of the assets for level 2. Everything that is created, is right here. We've got the outside environment. Floor, ceilings, wall. We've got these storage crates. We've got the probably the most important of all of them, or definitely the most important of all the objects, is the cube, the interactive cube that we're going to be using to interact with our other objects. This button here, which is made up of 2 parts actually, like the base and the actual button part that presses down, and then this portal. And that's what the players are going to be entering to exit or to enter the next level. First, we're going to be worrying about the environment. And like I said, we're going to be skipping over these storage crates because we determined during rehearsals we don't have time for that. But the environment is a wonderful place to start because it is just the most simplest. It's the most simple. We're going to start off as simple as possible. All we're going to do is add a plane to create the floor, adjust the size of that to make it the right dimensions, and then we're going to extrude that plane upwards to create walls and ceiling. Would you go down to extrude? We got a really good definition of it. Extruding is basically creating new geometry by stretching one component. And so the process of stretching a flat 2D shape vertically to create a 3D object. All right, but so
you'll see what that means in a second.
It's more of a
super
visual
obvious
concept, but you'll see that a lot of examples of that. We've got this YouTube link here, and we actually recorded the entire process of creating this. And so if you don't keep up, which this is a very simple one, so I'm sure you guys will be able to follow along. But if you want to revisit it in the future, you got a link to look over all of the steps of this process. Oh, no, not yet. Don't get excited.
Not yet. Soon.
All right. So the first thing I'm going to do, this is basically the default general file. So if you have modified your cube and you want to start over, you can either delete that cube and add a new one, or excuse me, don't add a new one, or you can do actually, you know what? You don't need to start a new file. Just delete whatever geometry you have, unless you want to keep whatever geometry you just created. And then you'd want to save. And I'll actually go over how to save right now because you want to save your file probably pretty early on so you have something to go to. Press Control S, or you can go up to the File menu to the top left and do Save. But I'm going to press Control S, and then I'm just going to name it as Level 2 ENV, standing for environment. And then I like to add a version number because I don't like having just one version of a file, especially while 3D modeling. I've had mysterious circumstances in the past. I'll explain a specific one. I was 3D modeling a character. I didn't have a saved file in between a work in progress state, so I messed up my current file, and somehow a corruption happened, and the hand was just wrong. No matter how much I undid, it was just wrong. I kept pressing undo, nothing changed. It was just a problem. It was a bug. How I fix that is honestly just by saving different versions of files every time you make like a big milestone in the 3D model so that you don't have to worry about doing that again no matter what happens. So save Blender file. And then, like I said, the first thing you're going to want to do is delete that geometry, whatever you have on there. So select that, right click, and then select delete. All right. And now we're going to want to do that first step, which was adding a plane. We already know how to add a mesh. Go to Add, Mesh, and then select plane instead of cube this time. All right. Everybody has a plane so far? Oh, all right. Just making sure we've got up to this point. Very good. So press the 7 on your number pad, not the top bar where the numbers are above your letters, but on your number pad, press number 7. That's going to bring you automatically to the top view. You've got other shortcuts on that number pad that do the same thing, but we'll go over that in time. For now, we want to be viewing it from the top view because we want to scale it, which is make it bigger or smaller. In this case, we want to scale it up, make it bigger, by the X, this red line, this X axis, and by the Y axis. To do that, you can do it in 2 ways, by going over to the scale tool, click that, and we'll start by the X axis. Click that red box that represents the X axis and drag it outwards. Next, we're going to scale it by the Y axis, and another way to do that is by pressing the S key on your keyboard and then Y right after. Then drag your cursor outward to about right here. It doesn't have to be exactly the way mine is, but kind of make that shape where the length or
If you want it to be a roughly 2-to-1 ratio, length to width.
yes. So now I'm gonna change my perspective by clicking the middle mouse button and rotating. And now we're going to go into edit mode. To do that, you're going to want to press tab on your keyboard, or like I said before, use this drop down menu. You make sure you're selecting the object, or it's not going to tab into edit mode. It's not going to do anything. Have that object selected, go into edit mode, and we, like I said in that video, we have different select tools so that we can select different components. We are going to want to select this last one, this third one that says face select when you hover over it. And then make sure you have that plane select the whole thing pretty much. Yeah, there's really not grabbing anything else in this case. So just click anywhere on the top face of that. We're going to want to extrude our geometry after that. So press the E key on your keyboard.
You'll see a Z axis pop up.
If you don't, press the Z key on your keyboard and that should bring it up. But for me, when I press E, it immediately scales on that axis if I pull upwards. Because that's the only way we can extrude that for now. If you're doing it on other geometry, you're just going to want to keep in mind that the direction you pull it is the direction you're most likely going to extrude it. Yeah, do it.
So as you can see, extrusion is a really, really important term and a really important technique in 3D modeling. As you can see, what Alfin did when he extruded was he added all this new geometry. He added walls and a ceiling, but he only did that by selecting the one plane.
Yeah, none of this right here was here before. It was just this right here. And so now you've got a good environment, and that's all for the actual environment part. After lunch, we're going to go into an introduction to how UV layouts work. That is our introduction to texturing. It'll show you how to texture your object, how to prepare it for texturing, and then how to do that later with Aaron.